Guys, it's Adam here. So there's been a really big breakthrough in condensed matter physics, which if this turns out to be legit, we're talking game changer. This would have a massive impact on things like climate change, the energy crisis that we currently face. It would like create a whole new range of products. Like you think, Marty McFly, hovering skateboard. You could potentially have trains that could go upside down along cityscapes. And the most important thing is it would reduce resistance or reduce energy losses due to resistance, which means batteries could be more efficient, power lines could distribute energy much better. So this breakthrough could be huge if it turns out to be legit. Now, first of all, like a few things to sort of say. Like, first, like forgive me because I'm doing this in one take, and you'll see me referencing my notes. Simply because I've just scribbled them down, and I'd rather. And the second thing is, I want to just get this out now because I feel there's not enough media attention on this. It feels like the kind of like the normal science bloggers and influencers are maybe like holding back or they haven't got their videos out yet. So I'd rather just do this in one take and break it down to you and explain what's going on. So you might be like, well, hold on a minute. You're like a sort of AI guy, techie, gamer, dev guy. It's not the sort of video I normally do, but like I said, those are the reasons why I'm doing this. And if you like it, let me know. If you don't, let me know. So let's start off. So a university in Seoul in Korea, they claimed that they managed to make a material superconducting at room temperature. So what that means is, as I said, it can display a thing called the Mesner effect, which allows it to levitate if induced in a magnetic field. So basically, it can float if you apply a magnetic field. If you ever have two north magnets and you put them together, usually what happens is the top one, it kind of repels, but it kind of falls off, right? It's not what you can't coordinate it. It's really hard to shape magnetic fields, which is why maglev trains are really hard. They're really expensive, right? It's like we've got a few demo ones, and there's maybe a couple of bigger ones in China, but generally they're really, really, really hard. So this would be a totally different kind of thing. So again, think Marty McFly hover skateboard because in theory, it's a lot easier to control. Now, the second thing is, as we said, it exhibits zero resistance. So this university claims that they managed to get both, right? So they've got the zero resistance, which allows it to, put power and put load in it, and it would be like really, really efficient. Now, here comes a scandal. So the team was like five people or maybe more, and one of the person on the team is an American Korean, and they've only got that person in simply because they feel if you've got an American or half American, you'll get published. And what happened was they rushed out a paper and then finally a second paper. So the first paper was published by three people, and the reason is because they only give out Nobel prizes to three people per team, and they had a team of five or maybe more. So backstabbing ensued. Now, obviously there's only so much we can say, right? Like I'm not there, I don't know the guys, but this is what tipped people onto this being a really big thing. Recently there'd actually been other breakthroughs in superconducting materials, but those breakthroughs turned out to be a dud. There was a couple of scandals where somebody made a breakthrough and it turned out it couldn't be replicated. So when like people kind of were skeptical on this one as well, which is probably why the news hasn't broken out so quickly, because people are like, yeah, we've seen this before, it's cried wolf. But when we saw people kind of stabbing them in the back to race out a paper so that they could get their Nobel Prize, people were like, okay, maybe they're onto something here. And it turns out that they are, because over the weekend, everybody scrambled, right? Like universities scrambled. There was a race, especially in China, I think in Wuhan, Nanjing Uni. So I've been to Nanjing Uni, I've been to Wuhan Uni, and I've been to Beijing, Nanjing. Anyway, so I've been to the lab where one of them was validated day before yesterday. So there are universities that have already validated this, right? So this is like massive. Now, obviously, there's questions like how much is the throughput of energy that it can handle? Like, is it as good at levitating as the ones that are super cooled? Like, these questions are all to be answered, and maybe it is like there's like limitations, but so far things are looking good. So I think this is where we're at right now. I just heard that some American unis are on this, so they're a bit slower, believe it or not, to pick this up. Um, and I guess more and more universities will be looking to try and replicate this. So the material, like I'm gonna go scroll down here, like it's lanarkite and a thing called copper phosphide. So it's like Pb2 and Cu3p. So it's like a white powder and like a grey powder. And I think you bake them in the oven and you do some bits and bobs. And the reason why this might be hard to validate is it's a little bit like anything, like really advanced. There's like ratios of mixing and there's like a lot of precision required. So I can imagine, we're not going to get all the answers straight away, but the fact that we've got early validations is extremely exciting. And this isn't like super exotic material either. So if this turns out to be legit, practical applications could come quite quickly. So I checked the stocks of American Superconductor and they're up like 250% in the year. So you can tell some people are getting really excited about this. So I think I've given reasons to be hyped, right? So like, you could think like I maybe be a little bit more practical, right? So you could get things like better supercomputers. If you're in the military, think railguns, right? Like the issue we've got with railguns is those, the two magnetic rods or rails. They usually get warped. I think America were working on a really big one, and it's just extremely hard. So again, if you had room temperature superconductors, this could be a game changer for that. Other things, like I say, you can imagine like batteries being like super, like much more efficient, and your battery could last a lot longer. I mean, your phones and your computers heat up, right? All of that is lost, right? That's energy lost to the environment. So in theory, this could be negated, and you could have massive gains. So like we're all pushing for fusion, but this might be the best interim gap that we've got to manage our energy crisis a little bit better. So I think those are the kind of like, obviously there's loads, right? There's like there's the dream ideas. There used to be adverts, I remember, in Asia of like cars floating above the ground, because people like I worked in Asia for a long time, and the period like during the early 2010s, there was a lot of hype. People thought we were really close, and I thought we were really close because I just finished my university degree about that time, and so I thought like it's a matter of years, because what happened was there was an arms race in the superconductor business, which was people were creating more and more complex ceramics. So generally ceramics seem to perform really well at low temperatures and exhibit this superconducting property. But obviously, to be practical, to make a business application, you want it as close to room temperature as you can. So each like 5 years there would be like a new ceramic, and it had like more letters on the end. It'd be like more compounds, and it would like bring the temperature slightly up. So it was like 220, minus 200, like 220. I think it was Kelvin. I'm not really thinking at the moment. But basically, we'll go with Celsius, right? So it's like, let's say minus 120, minus 100, minus 80, minus 50, and we were kind of slowly getting up the scale, but we couldn't, like, it slowed down, right? Like the returns, like there was like diminishing returns in the amount of improvement that was seen, because it seemed like they were limited by the structure of the material until this one. So it wasn't like an incremental gain, it's like a massive jump to room temperature. So this is, like I say, this is a massive breakthrough. Just trying to think if there's any other notes. Maybe I'll finish with like the reasons to be skeptical, right? So this has happened before, as I've mentioned, right? So there's been, obviously this is like cold fusion or something like that, or fusion. Like everybody thinks that they've made a breakthrough and then they haven't, and then it kind of further diminishes hope in the field. So this is possibly why this news hasn't broken as like hugely as say like ChatGPT or something, right? The throughput, this is just my thoughts here, but I would imagine there'll be limitations on the throughput. Like how much current can you put through this thing? But then even if there is, I would imagine that's an engineering problem to solve now. Like the fact that we've done it, right? So let's say you can get a current through, but if you put too much current through, you damage the material, which kind of makes sense, right? So I would imagine, like, then it's a case of, maybe making tiny, lots and lots of tiny um, rods of the thing or something like that. So there'll be engineering expertise that will come in, and they'll take something which seems close to reality and make it reality. Other things as well is, like, there are some universities that have claimed we've done it and we've got the zero resistance, but we haven't seen the magnetic levitation. So I think that was Nanjing University, and then some people said that's a bad batch. But then Wuhan University have published a paper today to say, yeah, we've seen both. We've got it levitating, and we've got the Messner effect exhibited. And we've got the zero resistance exhibited. So, like I say, this could be like really high precision and hard to replicate. But then again, like, so is doped semiconductors, right? So, like, some of the stuff that we create in our chip fabs are so unbelievably complex. And at the moment, this is like just two substances. So we'll see. This is kind of me done now. I don't really think I've got much else to say. Like, other than, like, at uni, I studied condensed matter physics. I sort of did physics at uni, and the hype that I had in some of my friends, we kind of assumed like this and metamaterials, like light bending materials would be done by now. Graphene, I think it was graphene, had the breakthrough. There's a breakthrough when I was at uni, and we all thought that we would have graphene infused products everywhere, and so that didn't really turn out to be the case. So I've got a lot of hope, but I've been burned in the past, and so we'll see. Like we've been burned in the past expectations wise, so we'll see how it goes. Again, apologies, I'm kind of like rambling now, so I'm going to wrap this up. But I just wanted to just share the thoughts and then explain what's actually going on. And maybe next time I can sort of talk more about the actual scandal between these students and these scientists, and why three of them rushed to get the paper out, and is it actually true that they only give free Nobel Prizes to up to 3 people? It seems like it is. So yeah, I mean, this is all exciting stuff. We'll just wait and see what actually happens.